Thinking about the evolution of the GTR. Skyline GTR. It has evolved along with the race. Challenge, feedback, and proof. And on to new challenges. The GTR has been forged in this way. I am proud that it has repeatedly reached the top of races and met people's expectations. At the same time, I am keenly aware that even greater heights await. And now, on to the R33 GTR. We have taken on the challenge of further expanding the area in which it can be controlled at will that was realized in the previous model. Controllable at will means the car moves as the driver intends, it does not move contrary to expectations, and the car speaks to the driver. From the planning stage, we concentrated each of the performances of running, turning, and stopping on one axis called driving performance, and carried out thorough development. By pursuing enhanced maneuverability, we have evolved the potential to fully utilize the capabilities of four wheels and provide the fun of driving. The 21-second reduction in lap time recorded by the R32 GTR at the Nürburgring is nothing less than an objective indicator of faster and safer driving performance. And now, the GTR has achieved a more practical potential increase, aiming to improve driving performance and durability under all conditions. One example of this is the newly designed large front spoiler equipped with a large opening air duct for cooling the brakes. This is proof that the GTR's driving has reached a level that can even be used for limit driving on a circuit. What did we do to make the most of the capabilities of all four wheels? Part 1, GTR chassis potential. Impact area of the four tires. In other words, it is essential to improve the performance of the tires and at the same time have chassis performance that can maximize the potential of the tires. This is the basis of the R33 GTR's goal of the ability to drive fast with confidence. We made improving cornering performance a major theme. To achieve this, rather than simply reducing understeer and making the characteristics more oversteer-oriented, it is necessary to first ensure stability, improve the ease of understanding of steering information and vehicle behavior, and then increase front grip. Specifically, we improved the suspension, steering, yaw rate feedback electric superhykas, tires and road wheels. We promoted comprehensive development of brakes, drive system, body rigidity, etc., and achieved expanding the range of control at will. Front multi-link suspension faithfully responds to the driver's steering. Accurately conveys information about the road surface. Ensures stability not only when driving straight and turning, but also when braking. The GTR's front multi-link suspension, which balances these qualities at a high level, has been further refined. It has evolved into a front suspension for stable, faster driving. For example, the upper link has a bifurcated structure that sandwiches the shock absorber, increasing camber rigidity by approximately 35%. By maximizing the potential of the tires up to their limit, the range in which the car can be controlled at will has been expanded. In addition, the spring constant, stabilizer diameter, shock absorber damping force characteristics, and bush rigidity have been tuned in conjunction with the rear suspension to significantly improve road contact. Furthermore, the addition of a front strut tower bar and a front crossbar has improved responsiveness to steering. It emphasizes the comfort of feeling as if your nerves are one with the car. Rear multi-link suspension. The GTR's driving is based on stability up to ultra-high speeds on the circuit. The main role of the rear suspension is to keep the tires firmly on the ground and ensure stability by suppressing changes in posture even when powerful driving and braking forces are applied. The rear multi-link suspension fulfills this role precisely. In this GTR, the wheel stroke on the bounding side has been increased by 10% compared to the previous model, further improving ground contact. This ensures that the tires are pressed firmly against the road surface in the correct posture, ensuring high stability. In addition, the high rigidity obtained through careful measures such as increasing the bush rigidity and increasing the camber rigidity by about 20% functions to fully utilize the potential of the rear legs. And all the elements that make up the four-wheel multi-link suspension, including the front legs, are integrated with all the vehicle components, large and small, to truly realize an expansion of the range that can be controlled at will. Electronically controlled power steering. Two types of hydraulic control valves are arranged in series to electronically control the appropriate amount of steering assist according to the driving conditions. When steering stationary, both valves are fully operated simultaneously to increase the amount of assist. At high speeds, only the first stage valve is operated to maintain firm steering force. The high-precision steering gear, polished to a micron level of 1/1000 mm, provides a direct steering feel. The joy of tracing the intended line through corners, and arrow-like straightness on the highway. The GTRS steering system allows the driver to control the car as he or she wishes and communicate with the road surface in a variety of situations, always giving the driver a sense of unity. It acts as an interface. Yaw Rate Feedback Electric Super Hikas was born to improve steering response and stability more faithful to the driver's senses. And the Yaw Rate Feedback Electric Super Hikas is an evolution of the function that directly leads to the expansion of the ability to control a car at will, further pursuing our idea that the driver comes first. This is the car that reads the driver's intention as the target yaw rate, and feedback controls the steering angle of the rear wheels so that the yaw rate actually occurring in the car matches the target yaw rate. This has given the GTR a new dimension of 4WS performance that can actively respond more faithfully to the driver's intention. The fun of pointing the nose precisely at the target point and clearing corners while staying perfectly on the line. The deep sense of security that maintains stable tracing even on rough paved roads and in strong crosswinds. It is a system that amplifies the close and trusting unity between the driver and the GTR. Brembo brake system plus high-performance ABS, achieving basic capabilities commensurate with the absolute power. Response to instantaneous sudden braking. And braking with a pedal feel appropriate to the braking. The role of the GTRS brakes is extremely important and demanding. It is a battle against heat. For this reason, we adopted a brake system made by the prestigious Italian company Brembo. Its greatest feature is the diamond-shaped lip used in the ventilation section of the large-diameter brake rotor, front 324 by 30 mm thick / rear 300 by 22 mm thick. This not only has excellent thermal strength and stress distribution, but also achieves a significantly larger surface area than conventional radial rectangular lips. Combined with the use of high-carbon material, it exhibits an extremely high heat dissipation effect, about 1.5 times that of the same size rotor in our cooling index ratio, ensuring sufficient fade resistance even under severe braking, such as when driving on a circuit. The front wheels also feature opposed piston aluminum calipers with different diameter dual pistons, with a small diameter of 38 on the entry side of the brake rotor and a large diameter of 444 on the exit side. The brake pads have a uniform surface pressure distribution. Together with the high rigidity calipers, it provides stable braking force and pedal feeling even at high speeds. Furthermore, the ABS, anti-lock brake system, that comes standard on the GTR provides stable braking on rough roads, as well as thorough tuning of ABS performance for sports driving. In addition to the overwhelmingly high braking performance when braking from high speeds, the system has improved line tracing performance by minimizing the behavior changes in the yaw direction, such as under/oversteer, which tend to occur during ABS control. This allows the ABS performance to be faithful to the driver's intentions and is appropriate on a variety of road surfaces, both dry and wet. It plays a part in the GTRS goal of being able to drive faster and more stably. Specially developed Potenza RE010 and 17X9JJ forged aluminum road wheels as part of our efforts to enhance the chassis potential of the GTR, we developed a high-performance tire. This tire is the Potenza RE010 245/45ZR17, specially developed for the GTR. While achieving an excellent balance between various requirements such as straight-line stability, cornering, and drainage, the tire's contact area has been made as wide as possible. This tire has achieved grip performance that reliably transmits the GTR's powerful high power to the road surface with stable traction and controllability. Moreover, the road wheels are newly developed 17-inch X9JJ forged aluminum. The wide rim allows the tire to use the entire tread width to grip and kick the road surface. In addition to being lightweight and highly rigid, it also has extremely high precision, such as roundness and uniform tensile strength. Brembo brake rotor ventilation structure. The ventilation section of the Brembo brake rotor is made up of 3 types of diamond-shaped ribs. This creates a much larger surface area than the general type, which has rectangular ribs arranged radially. Large opening air duct for brake cooling in the large front spoiler. A new large front spoiler has been adopted that increases the opening area of the air duct for brake cooling by 26%. By efficiently introducing a larger amount of running air, the brake cooling performance during continuous braking from high speeds on a circuit, etc., is improved by 20% compared to the conventional air duct. What should be inherited? What should be challenged? 2.6-liter twin-cam 24-valve twin-ceramic turbo, RB26DETT engine. This power unit has proven its absolute performance superiority and reliability through numerous victories, even in the N1 race specification with limited scope of modification. And for the R33 GTR, we sought room for evolution in the RB26DETT. In particular, we made various prototypes and verified the turbocharger. As a result, we confirmed that there is no better unit for the GTR at this stage. We pursued the best torque characteristics and throttle response for the R33 package, and worked to expand the range that can be controlled at will. We performed detailed tuning on a wide range of aspects, from the intake system to the exhaust system and engine control program. At the same time, we also refined the characteristics of the electronically controlled Truk Split 4WD Atessa ETS. Another new initiative was the installation of new air ducts in the front bumper, making full use of know-how gained from N1 racing to improve the engine's cooling performance. We'll leave the details of these to the pages that open this cover, but our theme was to refine the car to achieve more neutral and controllable handling performance, and based on that, to improve endurance for limit driving on the circuit. It is precisely because we possess assets worthy of inheritance that we take on the important role of challenging itself to further evolve. What we feel is the joy of being with the GTR. What did we do to fully utilize the capabilities of all 4 wheels? Part 2, GTR driving performance. Sodium-filled hollow exhaust valve. Metallic sodium is filled into the stem of the exhaust valve. Metallic sodium is solid at room temperature and liquefied at high temperatures, which increases the thermal conductivity of the entire exhaust valve and suppresses temperature rise. Direct-acting lightweight inner shim-type valve lifter. A shim that adjusts the valve clearance is placed on the inside to reduce the weight of the valve lifter. The lightness and response of the entire valve system is improved, raising the limit of valve surging at high revolutions. High-rigidity cylinder block. The explosive energy generated during the combustion process tries to push the head away from the cylinder block. In order to withstand this energy with ease, large head bolts are used. Combined with the rigidity of the engine and transmission connections and the high-rigidity design of the crankshaft and connecting rods, it is able to handle the high output of the RB26DETT engine. RB26DETT engine straight 6, 2,568 cubic centimeters twin cam 24 valve, 6 throttle chamber, intercooled twin ceramic turbo. While following the basic specifications that have proven its absolute superiority in races, the RB26DETT engine has improved performance as a power source for the GTR in a new package called the R33. The main menu is increased torque. The maximum boost pressure of the turbocharger has been increased from 570 mm of mercury to 620 mm of mercury, and the intake temperature has been lowered by a newly developed intercooler. The intake resistance has been reduced by a lightweight plastic air cleaner, and the ignition timing and mixture ratio have been refined. Maximum torque has been increased to 37.5 kgm/4400 rpm. It's easy to say this in words. However, the power unit of the GTR, which is designed to win races, is faced with unimaginably harsh conditions, such as the throttle being turned on and off in a split second. The control of the ignition timing and mixture ratio must be able to meet this demand. As I will explain in detail later, we used our own Hokkaido brewing ground and the famous Nürburgring as important stages for development. For example, in the final stage of tweaking the engine characteristics, the engineer in charge rode next to the test driver who had the ability to determine the characteristics to within 1 to 1 second. The driver's comments while driving were compared with the information from the data logger that kept recording the engine condition in detail, and the torque response while driving was refined repeatedly so that it would faithfully respond to the driver's will. In other words, we focused on satisfying the demand based on the driver's keen sense of "I need more torque here" when he momentarily pressed the accelerator. Even simple tasks such as controlling the ignition timing and fuel supply were organically synthesized by repeating this kind of running and verification. And the speedy control by the 16-bit centralized control engine computer, which has significantly increased the processing speed, supports stable and linear power response. The RB26DETT engine exclusively for the GTR. Its overwhelming power and controllable performance are the result of a perfect harmony of tradition and innovation. Twin ceramic turbocharger. As mentioned earlier, the turbocharger was retained. Compressor side, Garrett T3 type/turbine side, hybrid type T25 type with ceramic rotor. The lightweight ceramic turbine with a small moment of inertia realizes a sharp response from the low rotation range, and by installing it in twins, exhaust interference is prevented, and a linear and generous supercharging effect is achieved from the low speed range with low exhaust flow rate to the high speed range with large exhaust flow rate. Quick response and high power are both achieved throughout the entire range. In addition, the turbine material has been improved with the increase in maximum supercharging pressure. Durability and reliability have been improved. Inner fin type high-efficiency intercooler. The inner fin type is used for the intercooler, which cools the air pressurized by the turbocharger, increases its density, and further improves the supercharging effect. The core, called the conventional multi-hole tube type, was made of layered aluminum material with several holes running through it, and had a certain thickness inside. In contrast, the inner fin type is made of 0.1 mm thick aluminum fins that are wavy at 1.4 mm pitch and wrapped in aluminum plate, with all joints brazed. This has increased the heat dissipation from the conventional 16,800 kcal/H to 17,500 kcal/H. Same time, it has been made smaller and lighter. Since it is installed in the front overhang with cooling efficiency as the top priority, this weight reduction directly translates into a reduction in the vehicle's yaw moment of inertia. 6th throttle chamber. The 6th throttle chamber is one of the important items that support the GTR's sharp and linear throttle response. There are very few examples of it being used in mass-produced cars. This is a system in which the chamber is placed close to the cylinder head and a throttle valve is attached to each cylinder manifold. Since the capacity from the throttle valve to the intake port is small, the intake response to the throttle is quick. Not only does it provide overwhelming acceleration response at full throttle when driving on a circuit, but it also provides extremely sharp and flexible response in the partial range when driving normally. Exhaust system with large capacity muffler. Reducing exhaust resistance is essential to enhance power. However, this increases the exhaust discharge sound. In order to balance these conflicting themes and further refine the sound taste, a newly developed exhaust system has been adopted. First, the capacity of the rear muffler, which was previously 16 liters, has been increased to 19.1 liters. Moreover, the joints inside the muffler have been designed to allow the gas to flow smoothly, improving the sound quality of the exhaust discharge and reducing exhaust resistance. The larger diameter of the two front tubes just downstream of the twin turbos, $54,460.5, and the dual tail tube also contribute to reducing exhaust resistance. We hope you will enjoy the original power of the RB26 DETT along with this uplifting exhaust sound. We also hope you will enjoy the beautiful shine of the dual tail tubes, which are made of the highest quality stainless steel SUS 304 and have a color that changes subtly the more you drive. Electronically controlled torque split 4WD ATESA ETS. The core of the numerous technologies that exist to fully utilize the capabilities of all four wheels is the ATESA ETS, inherited and evolved from the R32 GTR. Based on FR, it is an electronically controlled torque split 4WD system that distributes torque to the front wheels in response to changes in driving conditions. The drive force distribution is continuously controlled from 0:100 FR equals rear two-wheel drive to 50:50 rigid 4WD. In addition to vehicle speed and accelerator opening, the drive force distribution to the front wheels is controlled according to the values detected by the wheel speed sensors of each of the four wheels, the front and rear G sensors, and the lateral G sensors. For example, when the difference in rotation speed between the front and rear wheels is small and the lateral G is large during turning, the front and rear torque distribution is brought closer to 0:100 to make it FR. Sharp turning ability and vehicle controllability by the accelerator are given top priority. Furthermore, when the difference in rotation speed between the front and rear wheels increases, part of the torque of the rear wheels is sent forward to optimize the yaw moment of the vehicle. It enhances vehicle stability and allows the powerful driving force of 4WD to exit corners. In addition, the torque distribution during high-speed cornering on dry roads, where large lateral G-forces are generated, is set slightly more toward the rear wheels than before in the R33 GTR. This further reduces understeer. When lateral G-forces are small, such as when starting, climbing, or accelerating in a straight line, or on low roads such as icy roads where the rear wheels have a large amount of slip, the torque distribution to the front wheels is increased to generate stable traction unique to 4WD. Furthermore, the comprehensive control of the torque split and ABS, anti-lock braking system, optimizes braking and ABS performance on various road surfaces. The GTR's electronically controlled torque split 4WD ATESA ETS. This further refined system conveys to the driver the joy of stable, faster, and more precise control in all driving situations. Key item for improving engine cooling performance: the front bumper now has the same air duct as the N1 race specification. This increases the air speed passing through the radiator, improving engine cooling performance. In addition, an air-cooled engine oil cooler that significantly improves oil temperature cooling performance when driving on a circuit has also been newly set as a dealer option. It can also be installed on cars equipped with air conditioning. Nismo Sports Engine Oil Cooler, air-cooled. The air-cooled engine oil cooler has high cooling efficiency and prevents oil performance degradation due to rising oil temperature and adverse effects on the engine itself, making it an essential item for sports on the circuit. It comes as a set with a dedicated air intake. Rear mechanical LSD. It optimizes torque distribution when the driving force of the left and right rear wheels changes due to driving on uneven roads or road surfaces with different left and right wheels, or when one wheel spins during cornering. The torque-sensitive mechanical LSD of the GTR responds more faithfully to accelerator operation than a rev-sensitive viscous LSD. It enables direct differential limiting and supports vehicle control through active accelerator work.